In this video, we're just going to generalize what they do on page 243 in the textbook. So we start with the product of x minus 1 times this general polynomial term, so 1 plus x squared, all the way up to x to the n minus 1. We want to multiply this big out. So think of it as like a big sort of FOIL problem. And what I mean by that is it's big because we have more than just a binomial by a binomial, right? This is a binomial times a polynomial. So every term in this first factor has to be multiplied by every term in this second factor. So x has to be multiplied by all of the terms, and negative 1 has to be multiplied by all these terms. So the way the book does it, and it's a good way to sort of recognize it, is we can think of this as x times 1 plus x squared all the way up to the n, x to the n minus 1 minus 1 times 1 plus x squared all the way up to x to the n minus 1, right? So the x is being multiplied by everything. That's what we're going to do in a minute. And then the negative 1 gets multiplied by everything. So let's do that. So the x gets multiplied by everything in the first term, in this polynomial. So x times 1 is x times x is x squared, x times x squared is x cubed. So in fact, what we see is the degree is just going up by 1 because I'm multiplying by another factor of x that's going to add 1 to the exponent for everything. And over here, when I distribute my negative 1 to everything, multiplying by negative 1 is just going to change the sign of everything. So this is going to be negative 1, negative x squared, negative x cubed, and we would just keep going until we get to negative x to the n minus 1. But we have some like terms here. Notice over here I've got a positive x, and over here I've got a negative x. So those are going to cancel. All right, so the positive x and the negative x are going to cancel. But actually, so will the positive x squared and the negative x squared, right? So those are going to cancel. We have a positive x cubed, negative x cubed, and in fact, everything's going to cancel with these terms. So I didn't write it, but right before here we have a positive x to the n minus 1. So that's going to cancel with the negative. So the only thing left is going to be just x to the n minus 1. So if we summarize what we just did here, we have, I didn't want to show you that whole part of the screen yet. This is what we have. We have what we just multiplied, x minus 1 times this whole polynomial gives us x to the n minus 1. So now if we divide both sides of the equation by x minus 1, we can cancel those factors. And so we're just left with the formula that you need to copy down into your workbook. The workbook has, I think, the left side, and you need to finish the right side. So this sum is going to be equal to x to the n minus 1 over x minus 1. And this is going to be an important formula we're going to use in this section.